好好啊。
来。
他等很久了。
那只要你。
你只要为了经历跟吃这个，
你不喜欢吃这个？
对啊。零食的。
会掉。
Okay, I think all of us are here, so let's get started. Okay, last time we talked about the first part of the YouTube design. I think a lot of us are not here, so I will do some brief review for the last time. Last time we talked about the video streaming and the video upload about the YouTube design system. And we have separated into two parts. The client means that the user who is watching the YouTube, and then we'll send the request to the video streaming, and everything else database is the API server. And for video streaming, we will send them into the CDN. Video streaming is not only the live streaming, but also when you watch the video, when you click the play button, you will start streaming the video. Yeah, and the primary concept we are using here is to separate the video into some smaller content. Like we don't need to download all the video to the user. We can separate them into small kind of content and send it to a user. And we can have some demonstration here. And when I start...
Yes. Could you share your screen in...
Online?
Yeah.
Oh, I didn't share? Oh, sorry. Let me see. Oh, I forget.
他们也没在听。
I need to apologize.
You mean
我也是啊。
你故意的？ No, I forget it.
Q 没有反应，所以没有在。
It's not on the call. Okay, so as you can see here, this is a whole YouTube video. And this is the pre-download section. So you can see the video has already downloaded from here to here. So if I click this part, it will skip and download this kind of part. You don't have to download all the video. So that's the primary concept. Okay, so today we are jumping to the next part. Okay, so last time we talked about the video transcoding. So today we are going to focus on video transcoding and also the video encoding. Okay. And the video transcoding here, they have some process. Let me show you on my PPT. Okay, the first part is about the preprocessor. Okay. Oh, sorry, let me show you the...
I think you're still not sharing your
screen?
Really? I think this one.
I think I can see your screen here.
Oh, what just happened?
Stop staring.
Are you sharing the wrong screen?
Oh, maybe. Oh, maybe you can reshow it again.
Robert, yeah.
Sorry. Oh, sorry, June. Let me just reshare the screen again.
Okay, June doesn't care. Go ahead, wait.
Can you see my screen, June? You can see. Okay. Okay.
Okay.
We will continue. Thank you, man. And this one is about the architecture, about the video transcoding. As you can see, the first part is the preprocessor, and the second part is the DAG scheduler. Last time we talked about the DAG. Okay, so this is an algorithm to make sure that all the video content is separated, dropped into several APIs, so they can decrease the loading of each API. Okay, so after the DAG scheduler, it will send to the job into the resource manager. And the resource manager will separate all the job into some proper task worker. So this is called API. Okay, so after everything's done, they will assemble the video together and start encoding the video. Okay, so let's deep insight to the preprocessor. The preprocessor has some important job. The first one is the video splitting. Okay, so last time we talked about we need to separate the video into the small content. So the preprocessor will doing this job. So they will separate the image into a GOP element. Okay. And some video didn't support the video speeding. Okay, so the preprocessor, if they found this, they will send the video speeding job on the online server. Okay, and after they separate the video content into a GOP content, they will start generating a DH scheduler. Okay, so this is important for the next part. Okay, so the DH scheduler is generated by the preprocessor. So they will know how to do the next job. Okay. So this is some code here. Okay, and the last one is the cache data. Okay, so this one is also the same with the first part. Okay, but some of them will go into the cache data, so they can have the resource managed more efficiency. Okay, so the second part is the DH scheduler. The DH scheduler here is to separate every job into some proper position. As you can see, the original video was separated into 3 parts. Okay, the first is video and the audio and the metadata. Okay, so last time we talked about this. So each of them will have some API. This is called the task worker here to afford the job. Okay, so as shown in this picture. Okay, so the DH scheduler, the most important part is to cache the job from the preprocessor and send their job into the resource manager. Okay, so I think the most important thing is like here, the resource manager. The YouTube speed, if you want to watch the YouTube more faster, I think the resource manager is very important. So they will have content 4 parts. The first part is task queue. The task queue is content the priority queue, the priority task inside. Okay, so this one is the worker. Worker, it contains the worker utilization info inside.
Did you upgrade it?
Okay, and the running queue. So it contains some running job inside, so they can make sure the status of the current job. If it's failed, it will send to retry again, or they can send it to another API to retry. Okay, so last one is task scheduler. It pick the optimal task worker and give them the task to execute. Okay, so the resource manager work as follow. Okay, I will show you the PowerPoint here. Okay, they will get highest priority task first and get optimal workers to execute them, and bind the running info into the running queue. And after the job is done, they will remove the job when it's done. Okay, so that was the primary picture of the resource manager. Okay, the next part is task worker. So this part is for several API. So maybe watermark API, or encoder API, or subnode API. And server API will have their own jobs to do. Okay, so the resource manager will handle the job for them. To them, sorry.
Who's that?
Okay.
Okay.
And we will have to get the information from the temporary shortage, or send some information to a temporary shortage. Okay, because we usually will cache some video content inside. So this is very important to have a temporary shortage to store some important data here. Okay, so when everything's done, and they will start encoding the video. Okay. And encoding video here is the next part. Okay. Do anyone have any question on the transcoding part?
So you just need up
This
to
picture?
part and basically the problem
Okay,
is
I will move
just
on
the
next part.
illustration.
Okay, so the encoding system is important on the security and the optimization. Okay, so I think the significant part to affect the speed of the encoding video is about the file extension. The file extension is very important here. Okay, so the name is also called the codex behind the whiteboard. Okay, so this part is a combination of coder and decoder. And the most popular code is file extension. Okay. Okay. So the most popular part is H.264 and the AVC. Okay, and the most popular codecs in audio is MP3 and LAC. I think MP3 is very old, but it's still popular because it supports all the content of the audio. Okay, so in the book we also mention about the container and also the codecs. The container is more like you have to put your information inside the file extension. So including the audio or the video or metadata. So the system or the API can find out all the information inside the file extension they need. Okay, so this is called a container. But codecs here is more like the file extension, due to my understanding. Okay, so the encoding job is very yeah.
Well, what I understand is that file extension, we call that a container. Is well, how do I put it? A file extension is a container, and that is irrelevant to the codecs. I mean, a container, you can imagine that a container will combine a codecs in video and a codecs in audio, which means, for example, MP4 is a container, and maybe it pick the video codecs like H.264 and the AAC for audio. It's more like a spec. It's more like spec. A file extension, which is a container, which is a spec for your video and your audio.
Okay.
So you have a combination. You have a combination of your video codec and your audio codec in a container.
Okay, I see. Okay, thanks for Nas for explaining this. Okay, so I was also confusing about this part when I trying to read this. Okay. So container is more like you combine the video H.264 or AAC together. Also, okay. Okay, so video encoding about the container and the codec is like this one, and then we will move on to the speed optimization. Okay, this one is we talked about last time. We will have to send all the jobs together to. We cannot send every job into one API. We need to separate the video content to a lot of server here. So this is called a parallelized video uploading. Okay, so different part will send to different API, and they will do the job together. And when the job is done, they will send the message to the competition handler. So the competition handler will tell the client this is done, so you can watch this part of video. Okay, so you don't have to wait until every API is done.
Can you remind me of what the GOP is?
GOP is the small unit image in a video. Yeah,
What
it means
does
that.
it stand for?
Okay,
Group of pictures.
Oh.
yeah, Google Picture.
Okay.
Yeah, Google Picture. Thank you. Okay. And in this part, okay, we will separate the job into different API. And the second one is to place upload center close to the user. So every region or every country will use the same upload center. So if you are in Asia, you will use the upload center in China. Okay. And this one is I talk about last minute. Okay. Oh, the upload center, the Asia upload center is in China. Only one upload center. Okay. And also the copyright system. the copyright system will separate in 3 concepts. The first one is a digital right management system. Okay, so this one we'll go back to books. Okay. Oh, by the way, this is the upper center of the world. You can see Chinese and Europe. This is France. Okay. And USA. And I don't know this country, maybe. Okay. Okay, so first part of the security here is digital right management system. Okay. And 3 of them are Apple Fair Play, Google Wi-Fi, and Microsoft Play Ready. So they will handle the copyright for you, for your content. So if you have some copyright issue, they will worry you about maybe your audio or maybe your video image is, how can I say that? It is using the other people's copyright. Okay, so the second part is AES encryption. This one is interesting. This one is mean that you can encrypt the video and configure the authorization policy. And okay, also this one is really interesting is because every time you want to encrypt your video, they will use the API to encrypt again. So every time when you're trying to access to this encryption, it will change the encryption code again. So you don't have to worry about the hacker will know about your encryption, because every time you access it, the system will reboot your encryption and regenerate a new key for you. So this one is really important for security. Okay, and the last one is visual watermark. Okay, maybe some image on your video.
Or it is done by server side?
I don't.
Okay.
You can ask.
And the last one is talk about the cost-saving optimization. Okay, this one is to decrease the CDN cost. Next time we're talking about this one is going to upload the most popular video or the most important video to the CDN database. So this is about kind of algorithm part. So this is why the reason they want to pop out the most popular video for user. Okay. Okay, and then we talk about the error handling. Oh, by the way, before we talk about error handling, let me show you one. If you go to the YouTube video and you're trying to inspect the video, okay, you can see the request here. You can click on the network and you can try to find your request. When you click play, you can see every new request will generate automatically. Okay, and if you jump the video part to the beginning, okay, they will also generate again. Or if you jump to the part that the video is not downloaded yet, okay, it will also generate a new part. And you can see a request here, the header. Okay, so maybe you can see the request URL to find out what is the code inside, maybe, because we don't know what is the source code. Okay. Okay, by the way, we talk about error handling here. And last time we are finding out there is a recoverable error or a non-recoverable error. If some content of the video is failed to transcode or encode, it will retry several times. But if they reach the retry limit, it will become a non-recoverable error. So if you encounter a non-recoverable error, the system will return the error to the client. Like you have to re-upload again, or you have to refresh your page again. And so also I can show you a source code here. This is about some retry function. Yeah, because sometimes we send the video to the video request to the server, this will encounter some error. So we have to retry again. Okay. Why I cannot unlock my screen?
要退出去。
Oh. How can I send the control?
Top right.
Oh. Okay, I will show you about one source code here. Go back to full screen. Okay, so this is a retry function. Okay, so as we can see, this one is going to retry the callback function here. And we will send the callback function as a parameter here. And this one, when we use a for loop to retry, and we set the retry time for the parameter here. Okay, so maybe the system will consider 10 times or 3 times as the retry limit. Okay, so the first time when you go through the for loop, they will send the callback function. Okay, so if it encounters some error, it will go through here, and they will minus the retry time. And after the for loop will reach the retry limit, they will go out from the for loop and store new error. So this is kind of a simple logic inside a retry function. Okay.
Callback 为什么没有 promise？
Callback 为什么没有 promise？
Oh, because maybe it's not a async function.
Like you are waiting there.
They are waiting there.
Oh.
44.
You mean the typing?
Oh wait.
Then you see the line 44.
Line.
You are
Right.
waiting a callback, but the
Yes.
callback is defined a generic type, not you are not defining.
I can't
It's-
see the.
This
There's a fetching function 39.
You mean on line 38?
Line
39, I
39.
think.
39?
What we are receiving for the function input.
We are returning a function.
We are returning a function.
turn this.
So we wrap the callback with the retry loop
Mhm.
and then return a function out of that.
I think we need a wait here.
Which part are you having
Because
doubts with?
He say the 44 line number 44.
Yes,
they
we are
getting
waiting callback, right?
So he is asking what kind of callback. What's the
Oh,
callback? type?
you mean T should have been a promise type? The return type of T should have been a promise type.
Mhm.
Yeah, maybe. No, kind of confused.
Let me think.
Return type where it is going.
What's your question?
But callback doesn't really have to be.
Is it a parameter, right? You are setting a callback as a parameter.
Yes, as the first parameter.
It's a generic. Okay. So you are assuming that it should be a
Sync function.
yeah.
Mm.
Might be a code review.
No. So it doesn't so T is a generic type, right?
Mm.
Yeah.
And even though the return type of callback was originally a promise type, on line number 22, T will be extending from the return type of T. Is that how you put it? So basically, if callback returns a promise, return type of T will naturally be a promise, right?
Mm.
Does that answer your question?
That's why the TypeScript code doesn't understand the avoid.
I mean,
Maybe this one.
maybe you why don't you put a promise wrapper of the T?
Promise wrapper,
Line number 38.
line number 38. Because the return, if the return type of
Oh,
T
you,
is already.
No, I mean the parameter
Mhm.
callback.
Parameter callback.
It is a T, right?
Yeah, it's a type T.
Okay, never mind.
Okay, we'll look at that later.
Okay.
Carry on.
This function is written by me and Steven. Yeah, so.
By the way, are you sharing the Gen 3?
Yeah, Gen 3.
And that June cannot see what we are discussing.
Oh, oh, I forget.
It's okay, she doesn't
It's a
Sorry.
multiple person.
Maybe I will send you the code after the meeting, or maybe next time when you're in office. Okay.
Okay, thank you.
Okay. Okay, so let's talk about the error handling. It's about the retry function here. Okay, so maybe the other part is about how to send to the server or API. If this API is reached the limitation, how will you send the error to another API? And how to manage the resource is another important part. Okay, but the book didn't talk about that, so we are going to dig into the error type here. The first one is upload error or the transcoding error. This one, they will just only retry several times. Okay, the second one is speed video error. Okay, if the client did not support the video splitting into GOP, okay, so that's why I say the entire video is passed to the server to deal with this request. Okay, and the preprocessor error, yeah, because we remember the preprocessor will generate a DHE scheduler in the end. Okay, so if something happen in this one, they will just regenerate the DHE again. Okay, so DHE is also, if they have some error encounter, they will reschedule a task because they will send the task into a resource manager. Okay, and how if the resource manager queue is down, they will use a replica here. Okay, this one is called a virtual node machine, run as part of internet computer. Okay, so if the local computer of the resource is going down, they will use the online source, the online virtual computer to do this job. Okay, so how about the task worker down? Okay, the API, if the API is down, they will retry on the new API. Okay. Okay, so that was the same. And how if the cache server down? The cache server is quite simple because we usually have a lot of nodes or a lot of computer who is copy the data from CDN. So if there is something going down, they can still copy the data from the other node. Okay, so how about the DB server down? They will just clone the data from the other backup DB server. Okay, so that was quite simple here. They didn't talk about a lot of detail. They just talk about how to deal with the error. Okay, so let's try to wrap up. Okay, so in this chapter we talk about the video transcoding and the video uploading. Okay, so they want us to focus on the scope of the API tier and the scope of the database and the live streaming. Okay, so live streaming is different from the normal streaming. It's because live streaming have a requirement of higher latency requirement. Okay, so they will need a different streaming protocol and they will be more expensive. Okay, but they will have a smaller requirement of the parallelism request. Okay. And also, last one is about the video takedown. If the video if the video is using the other people's copyright or some illegal content, they should be removed. So okay, so some of the API should deal with this, or maybe they will be generated by some user request. Okay, so that was today's content. Do anyone have any question today? Okay. If you don't have the question, maybe.
Complicated to have questions.
Maybe I think it's because I didn't explain well. So if you have some question, you can go to the YouTube and search for this video. I think this video is doing so well about this PDF. Yeah. You can search System Design Interview YouTube and find this video. This one is really useful. Okay. They will talk about a lot of detail here. Okay, so if there's no one question, we will end the meeting today. Okay.
Good
job.
Thank you.
Thank you.
Thank you.
Goodbye, Jun. Okay, so next time is Jim. Sadish?
Yeah.
Oh. Nice.
But you have to join at your 2 a.m.
Next one, design Google Drive.
Hiya.
这是一个低级的东西。
Okay, thank you guys. Yeah.
And
And
pause segregation. That's why we don't want pause segregation.
okay, remember to what?
Bring money in cash.
Yeah, we are going to have a new book maybe, so if you have any suggestion, remember to post it in the channel, alright? I think we will design.
It will be like Harry Potter.
Harry Potter.
Yeah. If you like, yeah, you can have the suggestion and maybe you can vote.
We want to work the Harry Potter again.
Okay, 好了，就这样吧，感谢。
Thank you, thank you.
Thank you, thank you.
Thank you.
忘记。
好，
谢谢。
我想想，是的，
强制章，就在。